Good afternoon again. Today's lesson is on statistics. What is statistics? Let's see if we can zero in on its importance in real life to have a basic understanding. Can you recall your class teacher taking register on a daily basis and you're wondering what's the purpose for it sometime? Well, you didn't know that your class teacher had to pass on that information to his or her supervisor, then to the vice principal or principal, then to the Ministry of Education. And this is what is done in every school within the country. Or maybe you are watching the news and you are seeing journalists presenting election polls on prospective candidates of an upcoming election for major political parties. How about business owners or managers talking about the amount of customers they have over their competitors and the profits they earned over a particular period? Oftentimes the bank does it every 3 months, every quarter, every 6 months, and stuff like that. How about you talking with your friends about the favorite snacks eaten by students at your school or in your class on a daily basis? Or you yourself checking on your daily followers on IG or Twitter or other social media platforms? What about the national census, which is done nearly every 10 years in the Western world, where a person comes to your house and try to find out the number of persons in the household, of those persons who are working, of old age, and so forth. And presently, the coronavirus data globally. All these scenarios require information or data to make decisions about institutions, people, resource allocation, and the development of self, community, and the country. So let's get into it. Let's define statistics. One definition of statistics is that statistics is the science of collecting. So when we do research, such as our SBAs or our final research in college, the science of collecting, organizing, analyzing, and presenting information, data to make informed decisions. That's one definition of statistics. So we collect it, then we organize it so we can analyze the information, then present it so persons around us can understand it. And of course, remember, mathematics is a language, and as such, it has a lot of content vocabulary. So we must practice using the terms and concepts. And statistics is one of those strands that has numerous terms and concepts to understand. Okay, let's recall some knowledge, or let's go into some terms that we must understand. Data. Data is information. That can be a description or figures about something. Data is information that can be a description or figures, numbers about something. Now, when we are doing research, whether formal or informal, we gather information, data, through a wide range of mediums. We can use questionnaires, we can use testing, we can use observation schedules, we can use interviews, different methods of surveys to collect the information that we want to make informed decisions in life. Information that we are researching on can also be called events. The data, the information can be called events. So here we can see why in some textbooks we see they link statistics and probability, because this concept we might have heard about it when we're doing probability, the probability of an event. So most times statistic questions are linked with probability questions. So the data, the information, what we are studying, we can refer to it as event. We can also refer to it as observation. We can also refer to it as variable. So new concepts coming out. So we must understand our questions. So if we're studying the test scores of students within a class, the weight of students, the score of a Batman, the coronavirus data, those are events, observation, the variable that we are researching. Okay? So when they interchange these concepts or terms, make sure you understand them in question. So the data that we're, or information that we are researching, we can be called event, observation, or variable. Okay. Now research data are of two forms. They can be qualitative or quantitative. Qualitative research data or information takes in a lot of observation. It describes characteristics. So we're talking about qualitative. So qualitative describe characteristics. So we say it uses a lot of observation, such as you might be studying the colors of houses on your block, the texture of materials used to make clothes or t-shirts, the behavior of a tribe living in Africa or South America, right? We might have to observe them in their natural environment. So it takes in a lot of words when talking about qualitative data or information during research. Quantitative, however, on the other hand, deal with numbers. Quantitative deal with numbers, and is further broken down or divided into two other forms, which is called discrete and continuous. So data can be qualitative and quantitative, which is further broken down in two different areas called discrete and continuous data. Discrete data is data that takes on a specific value. When you're doing research, we count, right? It takes on a specific value, specific. So for example, if we're doing a research on the number of children in a family and in a particular community, we can say a family has 1 child, 2 children, 3 children, or no children. But we don't say a family has 1.5 child or 3.7 children. It takes on specific numbers that we can count. Okay? For example, another example, maybe the British shoe size. Your shoe size might be size 4 or size 4.5, size 5 or size 5.5. You won't hear 4.7 based on the British method of establishing shoe size. So you get a whole number or a half shoe size. Or another example of discrete data, which we count the number of cars that passed your gate this morning between 6 and 10 a.m. 7 cars, 8 cars, not 7.5 cars. Okay? Continuous data now takes on any value within a certain interval. It takes on any value within a certain interval or range. Right? We measure when we're talking about continuous data. So when we're talking about height of something, weight, mass, we're talking about continuous data. For example, when we measure, we might be doing a research on the growth rate or the height of a tomato tree from germination to about 1 week, right? So the height of the tree, we might say the height goes through from 0.1, 0.2 centimeter, 0.3 centimeter, 1 centimeter, 1.2. It takes on any value between the interval that is set from germination to 2 or 1 weeks. Same thing goes for the height of a child. So the interval or the range we're talking about from 1 month to 12 years. The child might go to every specific value, while discrete takes on specific values. Okay? Now when data or information is gathered in a research in statistics, researchers has to organize and display for making conclusive judgment. Okay, let's get into it with some examples. For the nature of this, or for the purpose of this lesson, we'll be focusing on group and group data. So on group data is data that is not organized in group, basically as simple as that. It's not placed in group. So let's look at these data on group. So here we have some test scores for students, 50 students, marked out of 5. So this is an example of on group data. We're going to show what we mean by on group. Now, the first way in which researchers organize data. So this is maybe the raw data from observation. So say the test is marked out of 5. Some student got 1, some person got 5, some got 2, some got 3, and so forth. So the first way of organizing the data is to organize it in what is called frequency distribution table or frequency table or tally chart. So they can interchange those words and call it. So the frequency distribution table. How is it drawn? What is the event? What is the observation? What's the variable that we are studying? We're talking about scores. And we might have in the next column, we have tally. On the final column, we have frequency. Creating a table here. Okay, so the scores here is the event, the observation, the variable that we're studying. Okay, so the frequency is how often each score occurs out of the raw data. So normally we organize the frequency distribution table or the tally chart or frequency table in order. So smallest variable is 1, our observation. Then we have 2, we have 2, we have 3, 4, 5. That's the largest score. So we're going to check the fill in the tally now. We're going to see from the raw data how many ones are there. So we'll go through. Now sometimes students go all over the place and make errors by leaving out some. It's best to do it horizontally or vertically so we don't leave out anything. So how many ones can we observe? 1, 2, 3, 4, 5, 6. I'm doing it vertically. 7, 8, 9, 10, 11, 12, 13, 14. So we observe from the raw data there are 14 ones. So we're going to fill it in the tally. So 1, 2, 3, 4. And when we reach 5, we make a gate. So it's 14. 1, 2, 3, 4. And reach 5, we make a gate. 1, 2, 3, 4. And what goes in the frequency? The same thing as the tally. How many times we have seen 1 as a score? 14. And we do the same for the 2. Doing it vertically again. Score 2, seen here 1 time, 2 time, 3 time, 4 time, 5 time, 6 time, 7 time, 8 time, 9 time. See if we leave out any. See, made an error here, we left out 1. 10 times. So the score of 2 we saw it 10 times. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the frequency for the score 2 is 10. And that's how we do from the raw data and complete the frequency table. So this is what we call the frequency distribution table or the tally chart. Okay. So here we have a complete version of the frequency table. We have the scores, the number of tally for each score, which is the same thing that goes on with the frequency. And we oftentimes total the frequency. So it represents the data, because first we said it was 50 students, so we must get back the same amount. So we know there's an error if we don't get back the amount that's in the question. Now, sometimes the frequency table can be pre-drawn for you in questions. It can be done vertically, where they omit the tally part of the table and just put in the observation and the frequency only. And it can be done horizontally. We just put in the observation at the top here and the frequency at the bottom. So don't be confused. It's the same thing. So this is where the first thing that we do in organizing our raw data is put it in the frequency tables. We can do it vertically or horizontally. And sometimes they ask for the tally part of it. Sometimes it's not necessary. We do it vertically and horizontally. So it's the same thing. Now after organizing our raw data, and we say we're talking, this is showing on group. So the score, the observations are not in group. you soon see what we're talking about when we talk about group. And the focus will be on the score, the observation. So here it's on group. The data is on group. Now, to present our data, we normally present it on our XY plane. Some students don't realize when they draw the grid paper, it's still a representation of the XY plane. But what we are using is the fourth quadrant. We're not using the first, second, nor the third, but this quadrant. We're using the positive Y values and the positive X values. So oftentimes, it may look like this. So most time we draw just the positive Y side from the origin and the positive X side. So it's the same thing coming off of the XY plane. So most students don't realize that this is the quadrant that we're using when we're using in statistics. So we omit the negative values. We can draw it at the edge of the graph paper here, or we can draw it inside on the graph paper. It doesn't matter. Okay? All right. Now, using the same, so after they organize the data into frequency distribution table, then they might display it. They might display it on different types of graphs or diagrams. One such of them is the bar graph. We have proportionate bar graph, we have vertical column, we have chronological bar graph that shows years. But we're going to do a vertical one here. Alright, so we're using the same on-group data from the test scores. Okay, the observation, 50 students. Okay, importantly, we must, before we start, we must label our x-axis. What's it talking about? Scores. We must label our y-axis oftentimes with the word frequency. The frequency oftentimes goes on the y-axis, okay? And the observation goes on the x-axis. It's important, it must be labeled. And your graph should have a title. So whatever the question is asking about, you can write a short version of it at the top of your graph. Okay, it must have a title, it must be labeled on the y and on the x-axis. Okay, so we're going to draw our vertical bar graph from the raw data. So it moved from the, so we collect raw data when we're doing research, then we put it on the frequency distribution, then from the frequency distribution we put it on different graphs. So one such bar graph is a bar graph. Okay, now after drawing you'll see some characteristics of the bar graph. Okay, now on your y-axis here, which would be at the origin, we start at 0. You can label your y-axis however is suitable to you to catch the frequency. So the highest frequency here is 14, so you want to catch it, so you can label your frequency whichever you please to catch the highest frequency. So you can test it with your pencil, then erase and set it back over. Okay, now for the score you can have 0, 1, 2, 3. And if you observe, there's a reason why we skipped out the spaces between, because for bar graph, the width of the bar graph should be the same width and they should have even distance apart. Okay, so for the score 1, so we're going to label from here, so it's 5, 10, 15, 20. So based on how short my scale is here, we can see that our graph is not going to be very tall. But if you had labeled it with another scale with going up here, our bar will be taller. Alright, so from 1 to 14. So from 1, this line here is 15, so we'll go to 14 here. Okay. Okay. Okay, so 14 will fall just below 15 here. Next score, 2 to 10. Next score 3 to 12. So from 3 going up to 12, 12 will fall about right here. Sorry about that. 4 to 10. Sorry, I didn't extend it so far. So 4 to 10. And then 5 to 4. So 1, 2, 3, 4 will fall about here. So you observe the width of the bar graph are all the same, and they should have even space between. So once you set your values on your x-axis of the observation, set it so that the width of the bar graph should be same. They don't have to be so wide. You can set it however you want. You can make it smaller, wider, as long as it fits on the graph. So the width should be the same, and the distance between them should be the same apart. And the height of the bar graph tells you the frequency for each observation. Again, if you had extended your scale for the frequency, your bar graph will be taller, so it doesn't matter. Okay, another way of presenting our data is on a frequency polygon. So we're using the same data that we had from the test scores of the 50 students. So we're setting our scales 1, 2, 3, 4, 5, 6. Go a little bit over the observation. 0 here in the corner. Sorry. And then, okay, I'm going to use 5, 10, 15, 20. Okay, so it says 1 to 14. So 1 to 14. 2 to 10. 2 to 10. So what we are constructing is another method of displaying. So with a bar graph was done first, we're doing a frequency polygon. So this is another way of presenting the data. So we realize we are plotting points now. 3 to 10. 12 I mean. 4 to 10. And 5 to 4. And if you recall from lower grades, a polygon is a closed shape with straight line. So hence we're going to create straight lines. Let's use our pen here. So we're connecting the points. Okay. So this is another way of displaying the data using a frequency polygon. But as we say, definition of a polygon, a closed shape with straight lines. So we need to close this to form a shape. So we close this point here at the origin, and we close this point at the next value on the x-axis. Hence, we have a polygon, a closed shape with straight line, hence a frequency polygon. So it's the same ungroup data. We presented on the bar graph, we presented on what is called a frequency polygon. Okay, so we're on another method of displaying the data. We did bar graph, frequency polygon, now we're doing histogram. Now we're using another set of data. So this data consists of the number of heads on a coin that was tossed and the frequency. So it's a different set of observation from 0 to 6, and here we have the frequency. Okay, so we're going to put our observation on the x-axis and our frequency on the y-axis. So setting our table, so 0 as the origin, 0 here, then counting off our observation, we have 0, 0, skip a space, 1, skip another line, 2, skip another line, 3, skip another line, 4, skip another line, 5, skip another line, 6. So the frequency now, we're going to set our scales. I like to count by 5. So we say the farther up you're going, the highest frequency is 15. Okay? So how do you want to count? You want to count them by 1? So we could count each of these by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 1, since we have the space, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Since the highest frequency is 15, we can stop at that. Another person might count by 5 or by 10, whatever you want. The higher the frequency that you set on the scale here, the higher the graph is going to be. Alright, so the first thing now we're going to plot from 0 to 3. So with the histogram now, observe the first bar is like a bar graph, but the difference we'll soon see. So from 0 to 3, from 0 to 3, 0 to 3, bar. So the observation is always placed in the center, same like the bar graph of the bar that is created. So 0 to 3. With the bar graph, the vertical bar graph, we ensure that the space between the next bar and the previous one is the same. But with histogram, the bars are joined. So we're moving from 1 to 8. So 1 up to 8. So, okay. Two to 12. Okay. So this is a major difference between the histogram and the vertical bar graph. But you realize that. Okay. 3 to 15. So 3 is going all the way up to 15. Here. 15. But like the bar graph, vertical bar graph, the histogram, the width of the bars are the same. Then 4 to 13. 13 is right here. 4 to 13 on the y-axis. And then 5 to 7. 5 to 7 right here. Then finally 6 to 2. 6 going up to 2. So that's our histogram. So the main difference is that with the vertical bar graph and histogram is that the columns are joined. Observe, this observation begins at 0. So the bar graph is attached to the y-axis. Sometimes the observation for the histogram does not begin at 0. Might begin at 1 or a big higher number. When that occurs, the histogram is not joined to the frequency line or the y-axis, and we make a break like this to show that the data set or the observation, what the question is asking about, does not begin at 0. So because this one begins at 0, the first bar is joined with the y-axis. If not, we have to begin outside here. For example, we will put this like the art machine or seismograph machine, make a break like this, and it will begin our first bar, will begin somewhere out there. So when the data does not begin at 0, we start our histogram out there. Okay, so if the data begin at 5, 6, 7, then the graph would begin something like this with a break here. Okay, so that's another way of displaying it. So we've done the vertical bar graph, frequency polygon, and the histogram. Okay, now look at this. If we can observe, this is the group raw data for 100 people, the height of 100 people. But if you observe, the data is huge or large. Now in this case, because the data is so large, if we had to draw up a frequency table, the table would be very long. So make it more organized, we grouped it. So hence that's how the concept group and ungroup comes out. So the data set that we were working with before were ungrouped when you observe this section. But if you observe this frequency distribution table here, they have created what is called a group in the observation. So because the data is so large, they have set the data in a way so that all the data can hold, and the frequency distribution is not too tall. Okay? Sometimes the question will tell you the group that you want, or you can set your own group by counting in intervals of 5 or 10 or 20, whichever you please when you're doing your own research. But some concepts I want to bring out on group data. So the group data comes out with, well, when the data is too large, and you can do a bar graph, histogram, frequency polygon, or cumulative frequency to present the data. It's the same raw data you're presenting. So remember, after you collect your raw data in your research, you always put on a distribution table, and from that you put it on graphs, be it whichever you choose or what the question asks about. But let us understand. So in this distribution, this observation is placed into group. Now these numbers here, these observation is called class or class interval. So this is the first class, second class, third class, and so on. Okay, so look at the observe a pattern here, going up by 9 at the end here, going up by 0. So observation sometimes is very important. Okay, so the group that is put here is called a class interval, and this is called the first class, this is called the second class, this is called the third class interval, fourth class interval, and so on. So the group is called the class interval. And from this new idea of class interval, some other concept comes out. So say for example 100 to 109 is the first class interval, 100 to 109. Now within this class interval, or the first class in the distribution table, another concept comes out, our term class limit. The 100 is called a lower class limit, and the 109 is called the upper class limit. So the lower class limit of the class interval and the upper class limit. And remember, this is the first class, and the observation or the event, the variable we're talking about is height. So these are the height of 100 students. Okay, another concept come out is the mid value. So using this same first class, 100 to 109, if they ask to find the mid value or the midpoint, we had both of them, we average them. So we add 100 plus 109 and divide by 2, and that's our mid value. Again, within every class interval, the first number is called the lower class limit, and the second number is called the upper class limit. Another term, midpoint or mid value, is when we add the lower and upper limit and divide by 2 and get our result, and that's the midpoint. Another term, class boundary. So for using this same first class interval, the class boundary, one method of obtaining the class boundary is to subtract 0.5 from the lower class and add 0.5 to the upper class. And doing that, we'll get the lower class boundary and the upper class boundary. Again, for this first class, to get what is called class boundary, we subtract 0.5 from the lower class limit, and we add 0.5 to the upper class limit. So if we subtract 0.5, we'll get 99.5, and if we add 0.5 to this, we get 109.5. So this now becomes the lower class boundary, and this now becomes the upper class boundary. Finally, another concept comes out when you're talking about group data, is the class width. So we're looking at the same first class, 100 to 109. If you want the class width, the distance between the lower and the upper, we can simply count. So from 100, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109. So the class width there is 10. Or another method is by just subtracting the upper class boundary that you just got, which is 109.5. When I add 0.5 to this, subtract 99.5, which you subtract 0.5 and you still get the 10. And that's the class width. So these are some terms that comes out when we talk about group. So group is when the data is too large and we organize it in group. So okay, in the next video we go a little deeper into group data and presentation using the terms that we just talked about: class width, class midpoint, class limit, class boundary, and so forth. Thank you.